Hello students, Standard 10 Maths. Today we are learning the Thales Theorem from the chapter number 6, Triangles. Theorem 6.1. This theorem is very important from the board point of view because many times this theorem is already asked and various way they ask. Today we discuss about the Thales theorem and the questions pattern which they ask for the board examination. First question I write here, write and prove the Thales theorem. This Thales theorem is also known as a basic proportionality theorem. So sometimes they may ask this way, write and prove the basic proportionality theorem. Another way they may ask, prove that the statement of the Thales theorem is given. First of all, we discuss about this statement, then we prove it, that theorem, right? So the theorem is said, if any one line you draw, a line is drawn parallel to one side of a triangle. Suppose here we take the ABC triangle. In triangle ABC there are three sides, AB, BC and AC. This is three sides. Among these three sides, we select one side. For an example, we select as a BC side and we draw one line which is parallel to this BC side. So that's why the statement is given that way. A line is drawn parallel to one side of a triangle. And this line which is intersect the triangle ABC two sides, AB and AC. Where it is intersect, so we can say at the D point and at the E point. So the statement is that way, we have to write to intersect the other two sides in distinct points. These distinct points are D and E. These are the two sides AB and AC where our line D is intersect at point D and E at distinct points. If this condition is given in any triangle, a line is parallel to one side of a triangle and that line is intersect other two sides in distinct points, then we can say this line is divide the two sides AB and AC in the same ratio. That is our statement. The other two sides are divided in the same ratio. So basically geometric portion में आप कोई भी चीज़ फिगर से आप याद कर सकते हो. So here in triangle ABC I draw and triangle ABC में एक लाइन D ड्रॉ की है और D लाइन जो है वो साइड AB and AC को डिवाइड कर रही है. Here is AD, here is DB. AB is divided in two parts, AD and DB. Similarly, AC is divided in two parts, AE and EC. So that division of line sides is in the same ratio is there. So that theorem is called Thales theorem. And we need to prove this thing. AB is divided in AD by DB ratio. Similarly, AC is divided in AE by EC ratio. So as per the theorem, it is given, it's divided in the same ratio. So given we take in triangle ABC, DE is parallel to BC and this line D is intersect the side AB and AC at D and E point. And we need to prove that side AB is divided in AD by DB ratio is equal with side AC is divided in AE by EC ratio. Both ratios are equal. So for that we need to construct something. We need to construct. So here I mention what we have to construct to prove this theorem. And whenever, here I explaining you, whenever we write any triangle's area, and its formula is, area of triangle's formula is 1/2 into base into height. So for that, one by one we have to write all these segments, base we take as a base and triangle's area we write. So for an example, this is our triangle's base. So height is what? Height means its opposite sides from the vertex of the opposite. We have to draw one perpendicular to this base. and it is called the height of a triangle. So similarly, one by one, first of all we select this AD side. So for AD side, this is a triangle ABC is one of the side. So this is our base. For an example, suppose this is our base. So for drawing a height, we have to draw the one perpendicular from its opposite vertex. So here I am drawing one perpendicular. This is for an example EN. EN is perpendicular to side AB. EN is perpendicular to side AB. Similarly, whenever I take the AE line segment, and AE line segment is one of the side of triangle ADE, and if I consider it is a base, then we need to we have to draw one perpendicular from the opposite vertex. So this is, suppose we need to construct DM is a height of triangle ADE. So that thing we require to in construct. So we mention here we have to draw one EN is perpendicular to side AB, and another perpendicular we required for A line segment. DM is perpendicular to lines sides AC. Another thing, whenever we take the DB side as a base, DB side as a base, then we require, this is a triangle's one of the side. But as here we observe DBCE, this is DBCE is one of the side, and it is called the quadrilateral. Quadrilaterals construction we require into triangle. How you can draw? For that you have to draw one of the diagonals, so it is become a triangle. So here BDE, it is our one of the triangle, and for that we need to join B to E. Similarly, whenever we have take the EC as a base of the one of the triangle, we need to join this C and D. So that we have to write in construction, join B to E and join C to D. So that thing we have to require in construction. Now one by one triangles area we write using this formula, and we try to convert our triangles area in this form or in this ratio AD by DB. Similarly A by EC. Then after we need to prove both ratios are equal. So first I take the AD as a base, that type of triangle. So we can observe here AD as a base we take in triangle ADE. So we write that triangles ratio. Here I mention the proof of this theorem. So in triangle ADE, area of triangle ADE. So triangle's area formula is what? 1/2 into base into height. Here I select this triangle from the what we need to prove. According to we have to decide which triangle we have to take. Here I required AD line segment, so I select AD line segment as a one of the side of our triangle, and that side comes in triangle AD. That's why I select triangle ADE, and this triangle's area we write. AD is a base, and here EN is a height of this triangle. So according to the formula, 1/2 into base into height, this is our formula of area of triangles. So 1/2 into base as a AD, and height of this triangle ADE is EN. Now we have to write the DB as a base of the triangle's area. So DB is base means DB is one of the side of a triangle. So that one of the side comes in triangle BDE. This triangle, in this triangle we can say DB side comes as a one of the side of a triangle. So we select that triangle and its area we write in triangle BDE, and that triangle's area we need to write area of triangle BDE is equal to base as a DB means 1/2 into DB into height. Height means this DB line segment comes in a AB side, and AB's perpendicular is EN. So our this triangle's height is also En. So its height is become En. Now, as per the requirement of our proof, we require this AD and DB's ratio. So for that, here I take this two triangles areas ratio. Area of triangle ADE and area of triangle BDE. And area of triangle ADE is 1/2 into AD into EN, and area of triangle BDE is 1/2 into DB into EN. Now this half cancel out, this EN is cancel out. So here we get area of triangle ADE upon area of triangle BDE is equal to AD by DB. We give the equation number 1 which we use for this proof. So one of the ratio we get here in first one, and this ratio is equal with these two triangles area. Now for the another ratio, we select the triangle. AE is one of the side of the triangle. If we select, then it is a triangle AD is one of the side. This is AE. So according to what we need to prove, we have to select the triangle and its area we have to write. So AE is a side, one of the side of triangle AD. So according to in triangle ADE, we again write the area of triangle ADE, and that triangle's base is AE and its perpendicular is DM, so its height is DM. So area of triangle is defined by 1/2 into base into height. So here we take the base as a AE and height is a DM. Now we require EC. EC is a base, and EC is base is become a in triangle DEC. There is a one of the side is EC. So we write that triangle's area in triangle DEC. Area of triangle DEC is equal to EC is a base and its height. Its height comes in this EC segment comes in a AC sides one of the part, and DM is perpendicular to AC as we mentioned here. So that triangle's height is become a DM. So that triangle's area whenever we write, then 1/2 into base is EC and this base height is become DM. Now as we have need to prove AE by EC ratio, so again we take these two triangles area ratio, area of triangle ADE upon area of triangle DEC. So here 1/2 into AE into DM upon 1/2 into EC into DM. So DM is cancel out, half is cancel out. So we get AE upon EC. So here ratio of these two triangles area of triangle ADE and area of triangle DEC is equal with AE by EC. We give this as a second one. Here AE by AC ratio we get. Now as we need required, as I told you, first of all we get this two ratio and then after we prove them equal. So here right hand side per AD by DB and here right hand side per AE by EC. Now it's time to prove these two ratios are equal. So for that we have to observe its left hand side. In its left hand side both numerator is same triangle's area of triangle AD, and here is also area of triangle AD. Only different in denominator. Here is area of triangle BD and here is area of triangle DEC. These two triangles area is different. In numerator same triangle. So obvious we have to prove these two different triangles area is same. If we define these two denominators is same, then both equations left hand side is equal. So we can say both equations right hand side is equal, which we need to prove. So for that we observe these two triangles in a figure. Triangle BDE and triangle DEC. If we observe here, so in the figure triangle BDE is here, BDE, and triangle DEC is here. Observe these two triangles. we can say these two triangles lies on the same base DE. Both triangles common side is DE, and in the construct, or you can say in the given part, that line DE is parallel to BC. That line DE is parallel to BC. So in standard 9, chapter number 9, there is one theorem. If your two triangles lies on the same base and between the same parallel, then these two triangles area are equal. That theorem we use here, and then after we define these denominators, both triangles are equal. Here triangle BDE and triangle DEC are on the same base. On the same base. Same base is D. Both triangle lies on the same base D, and between the same parallel lines. Same parallel lines. Which lines? DE and BC are parallel, as we mentioned in given. DE and BC. So area of triangle BD, and area of triangle DEC, both are equal, and we give this as a number 3. So here we define these two triangles area are equal, and these two triangles are in equation 1 and second in denominator is there. So we can say it's both equations left hand part are equal, so that both equations right hand part is also equal. So both ratio are become equal. So from first, second and using third. So from 1, 2 and 3, AD upon DB is equal with AE upon EC. That thing we need to prove the ratio is equal. So that way you can prove the Thales theorem, or you can say basic proportionality theorem. Student, first of all you have to prepare this theorem and write down 2 times in your notebook. This is very important for the board exam point of view, and many times that theorem is already asked. So be prepared. Thank you.